Welcome guys to the third video, and we are going to get started. It's going to be titled 1.3 Properties. Okay, and we're going to learn about the different properties in addition and in multiplication today, and the essential question that we're going to try and answer is, how can you use properties of operations to solve problems? So let's go ahead and get into the terms. The first term is a commutative property. This is both for addition and multiplication. So commutative property. Okay? And what this is, if the order changes, and this is the order of the numbers, okay? They call them add-ins or factors if it's multiplication, add-ins if it's addition. So if the order changes, the sum for addition or product for multiplication, the sum or product stays the same. Okay, and what this necessarily means, or what this means is, like in addition, if you have, and this is just an example for this, it's not your actual example, this is just an example for the definition. If you have 12 plus 7, and you change that order to 7 plus 12, the answer is still going to be 19. Regardless of the order, the answer is going to be the same. The sum is going to be the same because that's for addition, right? So that's our addition example. Our multiplication example, okay, let's say we have 4 times 9. Well, it doesn't matter what order that is. It could be 9 times 4, and the answer is still going to be the same, 36. So the order, if the order changes, the sum or product, sum for addition, product for multiplication, stays the same. Okay? And that's commutative property. You can go ahead and write that down, pause it if you need to. I'm moving on. Then you have what's called the associative property. And this is both for addition and multiplication again. And when I think of associates, I think of like people that you would work with, that you'd be in a group with. And that's kind of how this works because it has to do with grouping. So if grouping factors or products, grouping add-ins or factors, If grouping add-ins, that's with your the numbers that you're adding, or factors, the numbers you're multiplying. So if grouping add-ins or factors, if grouping of add-ins or factors changes, the sum or product, sum if it's addition, product if it's multiplication, stays the same. Okay? If the grouping of add-ins or factors changes, I didn't put the grouping of, so sorry if you have to rewrite that. If the grouping of add-ins or factors changes, the sum or product, sum for addition, product for multiplication, stays the same. So this would look like this, okay? And you're going to see this with parentheses. Now, just so you know, the biggest mistake I see is students see parentheses, they automatically think, oh, it's associative property. That's not the case. You will see others with parentheses, other problems, and it will not be associative. I'll talk about that in a second. But in this one, right, when you're adding, if you change, so if we have 8 plus 14 in the parentheses, it doesn't matter, okay, if we have 8 plus 14 in the parentheses or 5 plus 8 in the parentheses, it's going to be the same answer regardless, okay? 5 plus 8 plus 14 is going to stay the same no matter where the parentheses are, okay? You could have it 5 plus 8 and then add 14, or 8 plus 14 and then add 5, and you're still going to get the same answer, okay? And that's the same for multiplication as well, okay? Here's what it would look like in multiplication. If you have 11 times 3 times 8, I'm just going to write it out first before I put the parentheses, okay? It doesn't matter if the parentheses are here or if they're here. The answer is still going to be the same, okay? And that's what that property is. Go ahead and make sure you write all that down. You can rewind and pause if you need to. Any questions you have, let me know. But we're moving on. The next one is called the identitive property. I just call it the ID property, okay? This is also for addition and multiplication. Basically says, for addition, okay, the sum, because you're adding, of any number and 0 is that same number, okay? And that's for addition. So, for example, okay, if I have 5 plus 0, it's still going to be 5. That's all it is. It's a lot simpler than you think. All it's saying is, hey, any number you add with 0 is going to be the same. Any number you add with 0 is going to be the same. That's all the identity property is. For multiplication, it's saying the product of any number, and product is the answer you get when you multiply. Same with sum. Sum is the answer you get when you add, okay? The product of any number and 1 is that same number. Any number times 1 equals the same exact number. So for this example, we could say, let's do 9 times 1. It's going to be 9. Okay? Any number times 1 is going to be that same number. That's what the identity property is. It's saying when you add something with a 0, it's going to be that same number. When you multiply it with a 1, it's going to be that same number. Okay, make sure you write that down. We're moving on. Last property is the distributive property. This is one we're really going to hit today. There's a lot on this. Okay, the distributive property is basically saying when you multiply a sum, I'm just going to put that, multiply a sum, which is addition. So when you multiply numbers that you've added together by a number, this definition is a little funky, so I'm going to write it down, but then I'm going to explain it. Okay, so don't get worried if this doesn't make sense. Multiplying a sum by a number is the same as multiplying each addend, the numbers that you've added, each addend by that number, and then adding the products. Okay, so what I mean by that, okay, here's the example. The best way to show you is just giving you an example. With distributive property, what they're saying is, if I have something like 5 times 7 plus 9, okay, so if I have two numbers, these are the addends, numbers that you're adding, okay, this is the same as me saying, hey, I'm just going to distribute the 5 into both the 7 and the 9. This is the same as 5 times 7 plus 5 times 9. That's all it's saying. Wow. Okay. It's saying 5 times 7 plus 9 is the same as 5 times 7 plus 5 times 9. Okay, let me give you another example. Okay. If I have, and this could be the same with subtraction. Okay. 2 times 10 minus 8. Okay. All you have to do is distribute the 2 into the 10 into the 8, and it's the same as 2 times 10 minus 2 times 8. Okay. That's what the distributive property is. It's saying you can distribute this number that you're going to multiply into the other numbers in the parentheses, and it would be the same answer. Okay? It would be the same exact answer. So, you're thinking, okay, these are all great definitions, but how are we going to see this, Mr. Morales? Well, we're going to see this in a couple examples. I'm going to give you 3 examples. This is going to help you with your mental math and with solving problems that you won't be able to solve with a calculator, or if you don't have a calculator. So let's say we have 8 times 59. Well, I could say, okay, this is the same as 8. I made a mistake here. I don't know what I did. How do I get rid of this? Oh, there we go. Okay, sorry about that, guys. I did something I've never done before, so I had a little technical difficulty. Okay, so let's say I have 8 times 59. That's the same as, all right, let me try this one more time. 8 times 59 is the same as 8 times 50 plus 9. So I kind of did the reverse distributive property there. I said, oh, okay, 8 times 59 is the same as 8 times 50 plus 9, right? Because 50 plus 9 is 59. This is the same. I know I could do 8 times 50 on my own, and I could do 8 times 9 on my own. And to me, this is a lot easier than me just trying to multiply 8 times 59. So when you have numbers like this, and you're like, oh, I don't know how to really multiply this. Well, say, okay, I don't know what 59 is, but I know 59 is 50 plus 9. I could do 8 times 50, because that's 400. Because 8 times 5 is 40, plus that 0 with the 50 makes it 400. I know 8 times 9 is 72. Now all I need to do is add 400 plus 72, and I get 472. Okay, so that's a good way to use distributive property. Okay, you could also say, write this down. Okay, I'm going to write something new, so pause that and write it down. But you could also say 8 times 59 is the same as 8 times 60 minus 1. And then what you could do is say, okay, I know 8 times 60 minus 8 times 1. Okay, 8 times 60 is 480. 8 times 1 is 8. Okay, 480 minus 8 is 472. Look at that. I got the same exact answer as before. Okay, so that's how we use distributive property. We say, okay, I don't know what 59 is, but I know it's 1 less than 60, so I can do 60 minus 1. Or I know it's 50 plus 9, so I can do that too. And that's a great way to use distributive property to solve a problem that you might not be able to solve otherwise. It helps you break it down into smaller pieces. We could use, let's do another example. We could say, I got 3 times 299. Well, I could say, oh, well, that's the same as 3 times 200, or no, sorry, not 200, 300 minus 1, right? And then put that sucker in parentheses and distribute. Say, okay, 3 times 300 minus 3 times 1. Well, I know 3 times 3 is 9, plus those 2 zeros right here means 900. 3 times 1 is 3. 900 minus 3 equals 897, and that would be my answer. Okay, so that's a great way to use distributive property. We can also use associative property. So I'm going to give you this example. If I have 5 times 23 times 2, I might want to break that down into smaller numbers. Say, oh, you know what? I need to solve this before I solve the others. Or you might want to even just say, hey, I'm going to use commutative property and switch it around. Do 5 times 2 times 23. Okay? Well, I'm going to do this one first because I think 5, I know 23 times 2 is 46. Okay? So now I got 5 times 46. Okay? And I say, oh, okay, that's the same as 5 times 40 plus 5 times 6, right? I know 5 times 40, 5 times 4 is 220, plus that extra 0 means it's 200. 5 plus 6 is 30, 230, okay? Or, if you want to do it easier using that commutative property, you could have just done 5 times 2 here, you would have gotten 10. 10 times 23 is 230. Okay, so that's how we use properties. We use them to solve problems in multiplication and addition that we might not be able to have solved otherwise. It helps us kind of break it down into smaller pieces so it's easier for us to work with. Thank you for watching. If you have any questions, please write them down. Have a good one.